Hello everyone, welcome to another video on the precise definition of a limit. That's calculus 1. Today I'm focusing on the rational function and the radical function. Now the question here says use the precise definition of a limit to prove that the limit, number 1, as x approaches 1 of 3x plus 6 over 2x plus 1 is equal to 3. Number 2 says limit as x approaches 1 of the positive square root of x plus 3 is equal to 2. Now if you substitute 1 here and there, the numerator becomes 3 times 1 is 3 plus 6, 9. 2 times 1 is 2 plus 1, 3. 9 over 3 is 3. Yes, correct. If you come here, you substitute 1 in there, it will be positive square root of 1 plus 3 is 4. And what is the positive square root of 4? The answer is 2. Right, so we prove the 2 in the same, I'm going to prove the 2 in the same video, and therefore I will have to move very quickly so that I do not extend this to 30 minutes or something. We need to try and do it within 20 minutes or within 20 minutes. Right, so let's look at number 1 then. Number 1, it says the limit as x approaches 1 of 3x plus 6 all over 2x plus 1 is equal to 2. Is equal to 3 actually. That's what it says. And I'm going to go to proof. Going straight, limit as x approaches 1 of 3x plus 6 all over 2x plus 1 is equal to 3 means for every epsilon greater than 0, there exists a delta which is greater than 0, such that if the absolute value of x minus 1 is less than delta or greater than 0, then the absolute value of our function 3x plus 6 over 2x plus 1 minus the limit, this should be less than epsilon. Now we move to our 4 steps. Step 1, the given step. What are we given? Well, we're given that epsilon is greater than 0. We go to choice of delta as step number 2. Choice of delta. I told you that if this expression here is not a linear function, delta will be the minimum. And we want the distance to be within 1. So minimum of 1 and another expression which we're going to determine here in terms of epsilon. Moving on to step number 3. It's our assumption step. So we assume, what do we assume? That this is true. We assume that 0 is less than the absolute value of x minus 1, and that's less than delta. Step number 4, which I call the notice step. What do we notice? We notice that 3x plus 6 over 2x plus 1 minus 3 simplifies to, I'm going to simplify this expression inside there. It simplifies to, remember, we can also write this as 3x plus 6 over 2x plus 1, and then I'm going to say minus 3 over 2x plus 1 all over 2x plus 1, like so. And now the denominator is the same. We can just have this as 3x plus 6 minus 2 minus 3 2x plus 1 all over 2x plus 1. Now, simplifying the numerator, let me rewrite that 3 there. But I'll come back and write that 3 in that place. Simplifying the numerator, what do we get? We get the following. We get the following. We simplify the numerator, we get the following. We get, if I may come over this side here, we're going to get the absolute value of 3x plus 6 minus, remember there's a 3 here, which I will come and write, minus 3 times 2x. Let me just copy that, 2x plus 1 all over 2x plus 1. We have to simplify this to the absolute value of 3x plus 6 minus 6x minus 3. Remember, minus 3 times that, minus 3 times 2x minus 6x minus 3 times positive 1 minus 3 all over 2x plus 1, like so. Absolute value of that. Numerator simplifies to minus 3x. These two give you minus 3x, and then 6 minus 3 is plus 3 all over 2x plus 1. Absolute value of that. I'll factorize the numerator into the if I factorize the numerator, it will be absolute value of minus 3 open brackets x minus 1 all over 2x plus 1, like so, which simplifies to, if you notice, absolute value of minus 3 times absolute value of x minus 1 divided by absolute value of 2x plus 1. Now let me rewrite this in case I forget there's a minus 3 there. Right, now, so absolute value of, if you check here, absolute value of minus 3 is 3, so this is 3 times absolute value of x minus 1 all over absolute value of 2x plus 1, like so. If you notice, in the assumption stage we said absolute value of x minus 1 is less than delta, so this can be written as less than 3 delta times 3 delta all over absolute value of 2x plus 1, like so, which I'm going to rewrite as 3 delta times, if you like, 3 delta over 1 times 1 all over absolute value of 2x plus 1, like so. And I can rewrite this so that delta is on its own, and I'm going to take 3 to the other side. So what do I have next? If I move to the next stage here of my proof, this is going to be, if I move down here, it's going to be exactly equal to, if you check, delta times 3 over absolute value 2x plus 1. Right. This is what I want to get rid of. I want to get rid of that. Now, remember, in the assumption stage here, we said the distance should be, in the choice of delta, we said the distance, the choice of delta would be a minimum of 1 and something. Why did we say 1? Because we want the distance between x and a to be within 1. So I'm now saying this part here, x minus 1 should be less than or equal to 1. So x minus 1, absolute value of that should be less than or equal to 1. Using the definition of absolute value, x minus 1 less than or equal to 1, but greater than or equal to minus 1. I'm going to add 1 here, there, and there. Why? Because I want x only here, so I can produce that expression within in the center there. So I'm going to add 1 here and there and there. This will be 0, less than or equal to x, less than or equal to 2. Now I have 2x here. I have to multiply the whole thing by 2. So 2 times 0, it will be 0, less than 2x, less than or equal to 4. 2 times 0, 2 times that, we get that. And we have plus 1, so I'm going to have to add 1 throughout. Adding 1, what do I have? I have 1 less than or equal to 2x plus 1 less than or equal to 5. Now, what do I do next? I reciprocate 1, reciprocate this expression here, and that inquiry sign must change now. So reciprocating 1, I get 1 greater than or equal to. Reciprocating this expression here, I'm going to get 2x plus 1. This will be greater than or equal to 1 over 5. Now, notice something. I have a 3 there. I can now multiply the whole thing by 3. So it will be 3 greater than or equal to 3 over 2x plus 1 greater than or equal to 3 over 5. If I take absolute value now, I'm going to get 3 greater than or equal to absolute value of 3 over 2x plus 1 should be greater than or equal to absolute value of that, which is if I may do this, 3 over 5. And obviously, if I rewrite this expression here, I'm going to get absolute value of 3 is 3 all over absolute value of 2x plus 1. And this will be less than or equal to absolute value of 3 is 3 and absolute value of 3 over 5 is 3 over 5. This is what I was interested in, this part here, if you notice. So now I can replace this one here by 3. So I'm going to say this is less than or equal to, remember here it's supposed to be less than, because we removed this expression here. We removed, wait a minute, no, less than is there in that space, but here we have to have an equal sign. Sorry about that. It's kind of a long process, so sometimes you kind of lose track of the signs, but there's an equal sign there. But now this will be less than or equal to delta times, remember this one here is replaced by 3 over here, if you can see it there. So we now are going to say times 3, and what is this? 3 delta. And if we set 3 delta to be equal to epsilon, what do we get? Delta will be equal to epsilon over 3. As we've done in the previous videos, this will be 3 times epsilon over 3, and the 3's cancel. The answer is epsilon. This should be the end of our proof, but remember we must take this and bring it where? Here, because we need the minimum. So it will be epsilon over 3. We're looking for the minimum of the two as our choice of delta. All right, that is the rational function, proving the existence of a limit by using the precise definition of a limit of a rational function. And I'm now moving on to the radical function. Right, our radical function we have here today is this one here. There it is. It says prove that the limit as x approaches 1 of the square root of positive square root of x plus 3 is equal to 2. So how do we prove this? Well, again, number 2, let me copy the question. It says the limit as x approaches 1 of square root of x plus 3 equals 2. If I may go straight into the proof, I'll say this means, so that's our proof. Number 2 means for every epsilon greater than 0, there exists a delta greater than 0, such that if the absolute value of x minus 1, which is the value of our a, is greater than 0 but less than delta, then the absolute value of the function, which is square root of x plus 3 minus the limit, should be less than epsilon. Now, we're moving on to our 4 steps. Step number 1, we state what we're given, and we're given that epsilon is greater than 0 over here. Step number 2, choice of delta. Remember, this one is not a linear function, so choice of delta, it will be delta will be the minimum of, we want the distance to be within 1, and another expression which we're going to determine there. Step number 3 is the assumption step or stage. What do we assume? We assume that this holds. 0 is less than absolute value of x minus 1, and that's less than delta. Step number 4, which I call the notice step. Your lecturer may call it something different, but this is how this is what I call it. So it's going to be the square root of x plus 3 minus 2, absolute value of this, simplifies, absolute value of that, simplifies. So how do we simplify this? Well, we use what we call conjugates. If you remember the difference of 2 squares, we're going to say this is exactly equal to the absolute value of square root of x plus 3 minus 2 times square root of x plus 3 plus 2, and we are going to divide by the same expression because we don't want to change this. X plus 3 square root of x plus 3 plus 2, like so. Well, because this is 1 and this times 1, it doesn't change this. But now I'm going to take the numerator together. This will be equal to square root of x plus 3 minus 2, absolute value of that, times absolute value of square root of x plus 3 plus 2 all over absolute value of square root of x plus 3 plus 2. Now the numerator obviously simplifies to square root of, absolute value of square root of 3, x plus 3 minus 2 in one bracket, square root of x plus 3 plus 2, like so, in another bracket. Absolute value of that all over absolute value of square root of x plus 3 plus 2. No need for us to put absolute values here because this is always positive, but let's just carry on because the tradition requires us to do that. In the numerator, if you use difference of two squares there, you'll agree with me that it simplifies to this. It simplifies to yeah, that's right. It simplifies to the absolute value of square root of x plus 3, like so, squared minus 2 squared, difference of two squares there applied, all over square root of x plus 3 plus 2, absolute value of that. And so in the numerator we have x plus 3 minus 2, like so, sorry, minus 4 actually, because 2 squared is 4, all over absolute value of square root of x plus 3 plus 2. So let me rewrite this 4 here just by removing some of the, but I'll come and just emphasize that again so that it's very clear for someone who is going to watch this video. Right, so this is what we have now. The numerator simplifies to x minus 1, absolute value of that, all of absolute value of square root of x plus 3 plus 2, absolute value of that. Now notice that absolute value of x minus 1, if you check in the assumption stage here, is less than delta. So we can now say this expression here is less than delta all over absolute value of square root of x plus 3 plus 2, which I can write this as delta times 1 over square root of 3 x plus 3 plus 2, absolute value of that. There is a problem, so I must get rid of this. Now how do I get rid of this? Well, same principle applies. If you remember, we said the distance between x and a, the distance between x and a should be within 1. So I'm going to take this part here and I'm going to say is less than or equal to 1 in the assumption stage if you remember. So we're saying absolute value of x minus 1 should be less than or equal to 1. And if you use the definition of absolute value there, this is what you get. And I have x plus 3 square root of that plus 2. I must produce this from there. So I start by getting rid of this one here. So I add 1 here, there, and there. I'm going to get 0 here. I'm going to get x there. I'm going to get 2 there. Now I have x plus 3, so I'm going to have to add 3 here, there, and there. This will be 3 less than or equal to x plus 3 less than or equal to 5. Now I have a square root here, so I must take square root. So square root of 3 less than or equal to square root of x plus 3 less than or equal to square root of 5. And then I have a plus 2 there. I must add 2 throughout. So I'm going to have 2 plus square root of 3 less than or equal to square root of 3, x plus 3 plus 2 less than or equal to 2 plus square root of 5. Now I have to reciprocate each of the terms because this is the reciprocal of that. So this means here I'm going to have 1 over 2 plus root 3. The inquest sign now must change to 1 over square root of x plus 3 plus 2 greater than or equal to 1 over 2 plus square root of 5. If I take absolute value, these terms will remain the same, but here I'm just going to have absolute value in the denominator. So therefore 1 over 2 plus root 3 greater than or equal to 1 over absolute value of square root of x plus 3 plus 2 greater than or equal to, that will be greater than or equal to, if you check, 1 over 2 plus square root of 5. Now if I rewrite this on another page, if I rewrite this expression here, I think on another page, let me rewrite it here. If I rewrite this part here, it's going to look like this. 1 over, if you check, square root of x plus 3 plus 2, absolute value of that will be less than or equal to, this will come on the other side now, 1 over 2 plus root 3. This must be greater than 1 over 2 plus root 5. I'm interested in this part here. So it means this one now can be replaced with that. But I must say less than or equal to. So what do I have now? So it means that, if I may have it here, it means that this is exactly equal to delta times 1 over 2 plus root 3, like so. So, which simplifies to, if you like, delta over 2 plus root 3. At this stage, remember we've arrived at that stage where we say set. If I say now set delta all over 2 plus root 3 to be equal to epsilon, solving for delta, it's going to be epsilon open brackets 2 plus root 3. This is the value of delta. It must come here. If I bring it here, it's going to be in the numerator. I'm going to have epsilon 2 plus root 3 all over 2 plus root 3. You can clearly see these cancel, and what do I have? That should be the end of my proof. But remember, our choice of delta, this one here, must come where? It must come here, where we say we're looking for minimum. So our choice of delta over here, our choice of delta, if I may hold these two together like this, our choice of delta is here. So we must take this, bring it here, and say we have minimum of 1 and epsilon 2 plus root 3. Whichever is smaller of the two would be our choice of delta. So this should complete our proof on rational and radical functions. If you're new to this channel, let's share these videos with friends and colleagues, and give these videos a thumbs up. It will help us to grow this channel and produce many more videos. I am very confident that this repetition of these concepts is actually helping somebody somewhere. All right, see you next time.